Hello! Welcome to an episode of Phys with Liv. Today we are talking about regulation of glomerular filtration rate, or GFR. To start this video, I want to start with some terms that I tend to forget what they mean, so you might need to take notes on these. First are macula densa cells. These cells are come up in this regulation of GFR, and they are sensory cells, communication cells that are epithelial cells of our distal convoluted tubule, which is also called the DCT of the nephron structure. And these cells are adjacent to the afferent arteriole. This arteriole is the vessel that brings blood to the glomerulus. Next, we have mesangial cells, and this name literally means middle of angle. The angle in this situation is formed between the afferent and efferent arterioles of the glomerulus. And these cells are found between granular cells within the glomerulus. They're found between our vessels, and then they're also scattered amongst the glomerulus. Finally, we have granular cells, and these are modified smooth muscle cell fibers, and they surround the blood vessels within the glomerulus. So they're found all over. And then finally, these are all cells within the juxtaglomerular apparatus. Now I don't know about you all, but when I see juxtaglomerular, I freak out because it has an X in it. But we always just need to calm, take a step back, and look at the parts. Juxta means next to or close to. Glomerular is literally referencing the glomerulus. So juxtaglomerular means next to the glomerulus. So all of these cells, these three, are within the glomerulus, and some are just outside. So that's all you need to know about that. Amazing. Now to the regulation of GFR. We are going to start with the, not that one, intrinsic regulation, which means it's directly in the kidney, in the glomerulus. So first we'll start off with our myogenic mechanism. And before I go into both of them, direct, intrinsic, these are both mechanisms of autoregulation. So if we have we start with systemic blood pressure drop in all these situations. For intrinsic, our goal is to increase glomerular filtration rate. So the one thing that can happen intrinsically is our myogenic mechanism. So the first thing that happens when we have a decrease of systemic blood pressure is a decrease in blood pressure in our afferent arterioles, which decreases GFR. And here I have that all this is in the afferent arterioles, so I'm just going to abbreviate AA for afferent arterioles. Okay, decrease in GFR. Next, because of that, we have a decreased stretch of smooth muscle in these arterioles. Amazing. So, decrease GFR, decrease blood pressure, decrease stretch. This leads to vasodilation of the afferent arterioles. And remember that vasodilation, dilation means that you're getting bigger, like when your eyes get dilated at the eye doctor. And vaso means blood vessel. So blood vessels get bigger, and this leads to an increase GFR. More blood can flow through this afferent arteriole to get within the nephron. Our other response to a decrease in systemic blood pressure that's intrinsic is our tubuloglomerular mechanism. So our first response, the first thing within this mechanism is just a decrease in GFR, like in our myogenic. Okay, next thing, because of our decreased GFR, we have decreased filtrate flow and decreased sodium chloride in the ascending limb of the nephron loop. So we have our nephron loop, and we have decreased filtrate flow. And decreased sodium chloride or salt in the ascending limb. Great. What happens next? Well, because of this, in our ascending limb of the nephron loop, we have action, lights, camera, action, on our macula densa cells of our juxtaglomerular complex. So we're in our kidneys, our macula densa, those cells that are part of our DCT. So this box, we act on our macula densa cells. Which are in the kidney. So instead of juxtaglomerular, I'm going to say JXG complex. And so action on that leads to the release of vasoactive chemicals is inhibited. So we're going to make this arrow be an extended arrow, and that means inhibit, release of vasoactive chemicals. And so, if we don't have vasoactive chemicals being released, and these vasoactive chemicals are usually constricting our blood flow, they also just control our blood vessels, we have a result that of vasodilation in our afferent arterioles. So we're back to our friends, the afferent arterioles. Crazy. So we have a vasodilation of our afferent arterioles. Crazy thing how both of these match. They're both the same thing to increase our glomerular filtration rate. Amazing. So this inhibition also affects our extrinsic regulation. And extrinsic can also mean indirect. So this stuff is happening outside of our nephron complex right away. Well, it has factors not right away. I should say it is acting not like close neighbors. We have to go to the next city over to bring back our resources for what we need. So we are having a decrease in systemic blood pressure, just like before. Our first extrinsic thing that can happen is a hormonal regulation, our RAA system, or renin, angiotensin, aldosterone system. So the first thing that happens here, we have our granular cells, remember those, are involved. Granular cells involved. of juxtaglomerular complex. So yes, this is in the kidney. And these release our granular cells are releasing our renin. And remember, renin is different than renin. Renin is the protein, renin is the enzyme. And this renin catalyzes a cascade that allows for the formation of angiotensin 2. Angiotensin, oops, I'm out of my box. 2, Roman numeral 2. So we'll just say cascade. Great. So, decrease systemic blood pressure. We're at angiotensin 2. Now this guy has two effects. One goes to the adrenal gland, which is the little hat on top of your kidney. And the other one goes to our blood vessels. So let's go to our blood vessels first. Angiotensin 2 causes vasoconstriction of systemic, which increases peripheral resistance. So vasoconstriction of systemic and this is increasing peripheral resistance. So we are kind of shunting our blood, constricting to reduce blood flow to our system so then we can get more blood somewhere else. Great, so this goes to systemic blood pressure to increase it right away. That's our main goal of the extrinsic regulation. Okay, back to angiotensin 2 and our hat of our kidney, our adrenal gland. So in our adrenal gland, we have an increase of aldosterone secretion, our second A of RAA. So increase aldosterone, which own hormone goes in the blood, secretion, increase aldosterone secretion. Great. Aldosterone secretion means that we have an increased sodium absorption in the kidney tubules. Increase sodium ion reabsorption. We're in the nephron now. And with an increase of reabsorption of our sodium, we have water that follows. So if we have water following, we have more fluid, which, if we have more fluid, we have an increased blood volume. Increased blood volume. Increased blood volume, increased blood pressure. Okay, our last mechanism of regulation of GFR is our neural control. And as you can see, it's kind of shorter, and we have two steps, our blood vessels and our nervous system. So our first response to a decrease of systemic blood pressure is an inhibition of baroreceptors in our blood vessels in our systemic circulation. So we have our baroreceptors of systemic circulation inhibition. And remember that baroreceptors are sensing pressure changes. So that just makes sense. Decreased blood pressure, we have our pressure sensors going off. Ding, 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 something's wrong, we gotta fix it. And so when our blood vessels have their pressure sensors going off, like in your car, the annoying beep, 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 that signals to the sympathetic nervous system. So sympathetic nervous system. And the sympathetic nervous system is like the control freak. It does everything it can to fix it. It goes straight vasoconstrict. Sympathetic, vasoconstrict, increase blood pressure. Also, sympathetic nervous system talks to our glomerular cells in our kidney and has this whole humoral effect with our RAA system. So as a refresher, summary, to regulate glomerular filtration rate, extrinsic or indirect, we've got a humoral blood hormone system to increase systemic blood pressure. And we have a neural control to increase systemic blood pressure using our sympathetic. We also have intrinsic regulation, so directly in the kidney. We don't need to go outside of the kidney for this. We have our myogenic and our tubulo-glomerular mechanism. And both of these work to increase our GFR. GFR is much easier to say than glomerular filtration rate, by the way. All right, that's that. Have a great day.